We continue with more on the application of trigonometry. Herein we take up a little higher tier questions from the previous session. Let me just write it down first. The first one, these are though also kind of preparatory questions. This is I think from one of the past papers as well. Elevation, the important part of such any application of trigonometry is always about getting the figure correct. Then calculation part is more an extension of how far the trigonometric ratio is good. The angle of elevation of an aeroplane from a point A on the ground is 60 degrees. After the flight of only 15 seconds, I'm using some short form so that I finish writing the question quickly. Angle of elevation changes to 30 degree. Obviously, if it is changing the position, the angle of this will also change, the angle of elevation, sorry. Now the question is, if the aeroplane is flying at a constant constant height, that means it is horizontally just flying, height of 1500 root 3 meter. Find the speed of the aeroplane. Right, let us see how does this happen. Now the aeroplane is flying at a height horizontally because it says it is at the same height. Okay, so this is the same height. Now I draw let me just draw this part. This is the time. I'm sorry for the not so straight line below. Now this is A, B, C, D, E. Now C and D are the positions of the aeroplane. So the height will be ED as well as BC. They both are, it says, at a height of 1500 root 3 meter. The angle of elevation of an aeroplane from a point A on the ground is 60. Suppose this is 60, the aeroplane is at point D. This is 60. After a flight of 15 seconds, that means after 15 seconds the position of the aeroplane has changed from D to C. In that case, the angle of elevation also changes. I'll be using another color to make it separate. And this angle is now changed to give you a 30 degree angle of elevation. Now it says CD is at a constant height of this. Find the speed of the aeroplane. How do we find the speed of the aeroplane? To find the speed is always given as distance by time. The time is given that aeroplane is flying for 15 seconds. But how far is the distance which has the aeroplane traveled from D to C? So we need to find that distance which is D to C, which will be given in meter because rest of them in meter, and this time is given in 15 seconds. So we'll find the speed as meter per second. So our task is to find DC from the figure given. We have been given two triangles. One is this triangle ABC. If you apply the trigonometric ratio to ABC, I can take a relation which says tan 30 is equal to BC by AB. Right? Yeah. So tan 30, where is tan 30, is 1 upon root 3. BC is 1500 root 3 by AB is the question. So I continued that below so that I can use the rest of the space for more calculation. AB is 1500 root 3 into root 3, that gives you 1500 into 3, so that's 4500 meter. Alright, that means this whole length is 4500 meter. Now if I can find AE, that I subtract from 4500 should give me EB, which is equivalent to DC and the length, which has the distance which the aeroplane has covered. So now we let us sorry, concentrate on the triangle AED. Okay, AED. In that case, we have been given tan 60 relation with DE and AE. Now DE is also equal to BC because the height of the at which the aeroplane was flying. What is tan 60? Tan 60 is root 3. DE is 1500 root 3 by A is what we are calculating. So AE I'm sorry again is 1500 root 3 by root 3, that makes it 1500 meter. Now if AE is 1500 meter, we can subtract this AB minus AE to get our EB. So that will be the distance covered by the aeroplane in 15 seconds. So 1500 to be subtracted from 4500, that's giving us 3000 meter. Now let us replace that 3000 meter here, because that's how we will be calculating our speed. So 3000 by 15 is 200 meter per second. If we need to convert it into kilometer per hour, that also you can do and find, and that I guess you can do by yourself. That will give you the answer of 720 kilometer per hour. Now I'll just give you another question we'll discuss, but I leave the calculation to you to do. I'm not giving that difficult question, so don't worry. It is similar to one of the previous questions I had discussed. Okay, I write it down. A person observed angle of elevation, let it be short, angle of elevation of the top of a tower as 30 degree. He walked 50 meter towards the foot of the tower along level ground and found the angle of elevation of the top of the tower as 60 degrees. Find the height of the tower. So let us draw the figure to ourselves. A person observed the, oh God, I have written this spelling. just ignore it. This is suppose the tower, which is I name as AB. The person observed the angle of the top of the tower as 30 degrees. Suppose he is standing here, which has made the angle 30 degree. This is the person C. He walked 50 meters towards the tower. That means he started at this point C and will now be moving towards B, because B is the foot of the tower. Suppose this is 50 meters. He has walked from C 50 meters to the point D. At that point, he found the angle of the top of the tower to be 60 degree. Again, we draw the angle of elevation here. That means this angle is given to be 60 degree. Find the height of the tower, which is AB. Now we will be getting two relations. One is in the triangle ABC. That's giving you tan 30 is equal to, let me just name this BD to be X. Tan 30 is AB by the whole base, that is 50 plus X. There can be, and now tan 30 is replaced, I think that is root 3 is equal to AB by 50 plus X, and you get 1 AB, which is given as 50 plus X into root 3. Another relation which we get is actually tan 60. Tan 60 is again AB by X. Tan 60 I think is root. Tan 30 is I just forgot. Tan 30 I think is 1 by root 3. I made a mistake here. And tan 60 I think is root 3. So this is AB by X. Again you get one AB here, which is root 3 X. Let me just check if I'm doing it right or not. Yeah. In that case, tan 60 is root 3. Yes, I've done it right. And 30 is 1 upon root 3. Yeah. Now you have got these two ABs. So AB cannot have the two different values, so that has to be equated now. It is up to you, I leave. Solve this and find the value of X, thereby finding AB. Okay. I give the value to, because see, your question is find the height of the tower, right? The height of the tower is AB. So you need to find X first and then you can find AB. So equate this equation 1 and equation 2 to find X. Then in either of the equations, if you substitute X, you will be getting your AB, which is height of the tower. I hope you get them right. Do I give you the answer? I better be. You will get AB, the height of the tower, to be 43.25 meter when you replace root 3. Happy solving. Thank you.